method of Lagrange multiplier. Suppose we want to maximize or minimize f of xy. This f is a function of two variables, x and y, such that this constraint equation is satisfied. This is the constraint. This is the function to be either maximized or minimized. So function g x y function ni aduga x y is not condition satisfied g equal to 0 satisfied. Let the extreme value of f xy subject to the constraint g xy be k. Let k be the extreme value of f subject to the condition g equal to 0. And let this extreme value be obtained at the point x0, y0. By examining the contours of f, we see that at the extreme point, the curve g equal to 0 must touch the level curve f equal to k. Because if the curve g equal to 0 cuts across the level curve fxy equal to k, one can still move the point along g equal to 0 so as to increase or decrease the value of f. Extreme point at the extreme point, the graph of f equal to k and g equal to 0 must touch at one point. Tangent or straight line or tangent or to cut across cut across more than one point. I repeat, cut across more than one point. More than one point tangent cut across point point the extremum it should only touch the level curve. Touch tangent when touch. So let me give you one example. The example is this. Find the maxima or minima of this function 3x plus 4y such that x and y satisfies this condition, x squared plus y squared equal to 1. So what is the constraint? This is the constraint. And what is the function to be extremized? This is the function to be extremized. Sigi constraint g it only. So g equal to 0 even we take right hand side to the left hand side with a minus sign. So what do you get? G xy equal to x squared plus y squared minus 1. So this is g and g equal to 0. This is the constraint. This is the constraint. So the constraint equation. So it's x squared plus y squared equal to 1. So equation now. This is the equation of a circle. This is the equation of a circle with center at the origin and radius 1. So I draw a circle. With center at the origin and radius 1. And radius 1. And what is this? 3x plus 4y. 3x plus 4y. F xy equal to k. Function f equal to maximum values or touch at the extreme point, the curve, the level curve fxy equal to k should touch g. At the extreme point, you set this 3xy plus 3x plus 4y equal to some constant. 3x plus 4y equal to some constant and Hana fixed order. 3x plus 4y equal to some constant. What is this equation? This is the equation of a straight line. This is the equation of a straight line. So for different values of C, I'll get different lines. So for different values of C, I'll get different lines. Let me draw the lines here. For different values of C, I'll get different lines. So all these lines will be parallel to each other. For different values of C, I'll get different lines, and all these lines will be parallel to each other. For different values of C, I'll get different lines, and all these lines are parallel to each other. The extremum among all these lines, what are the extremums? The extremum those lines which cut the G equal to 0 surface, at which only touch the G equal to 0 surface at one point. C lines in here. C line C value though. The value of C for this line is the extremum value, which we call K. Touch touch touch, so there are two extrema. So this can be also K. K can have two values. So K1 koroge, so K2 koroge. Touch togdagadi, cut across the this line will cut the surface, sorry, the curve G equal to 0 at 2 points. 2 points about 2 points. Aduna karigumba Sigi lines cut across the torgadi, we can move this line parallel to each other towards right. When we move towards right, the value of C increases. When we move towards left, the value of C decreases. So along this line, the value of C increases. So along this line, the value of C decreases. Extremum value the value for which the C is a maximum. Extremum value of the value at which C is either a maximum or a minimum. That is called the extremum value. So here we get the maximum value. Here we get the minimum value. By examining the contours of F, we see that at the extreme point, the curve G equal to 0 must touch the level curve. This because of the curve. Because if the curve cut across the level curve on one, so cut across the level curve of Korgadi, one can still move the point along Gxy equal to 0 so as to increase or decrease the value of F. So the cut across the Korgadi, I can move the line parallel to itself. When I move it parallel to itself, the value of this function changes. The value of C changes. I'm going to touch the point. Is the extremum value on narrow. So at the point where this F, or where this line touch the curve G, the gradient of F. The gradient of F is along this direction. And the gradient of this curve, is also along this direction. So at the extrema, the gradient of F and gradient of G, they are parallel to each other. Similarly, at this extrema, the gradient of F is along this direction, and the gradient of G is along this direction, and these two are parallel to each other. They can be either parallel or anti-parallel. At the point of extremum, gradient of F should be equal to lambda times the gradient of G. So this is the given function. This is the given function. This is the constraint. So find the maximum or minimum value of this function. I have any. A condition gradient of F should be equal to lambda times the gradient of G. So first, let us calculate the gradient of F. Gradient of F, you differentiate this F first with respect to X. This is 3x plus 4y. If you differentiate this with respect to X, what do you get? 3 I cap. Plus, then you differentiate this again with respect to Y. If you differentiate this with respect to Y, what do you get? 4. 4j cap. So this is the gradient of f, and this is g. So if you differentiate this with respect to x, you get twice x I cap. If you differentiate this with respect to y, you get twice y j cap. Twice x I cap plus twice y j cap. So this is gradient of f, this is gradient of g, and the method of Lagrange multiplier. Method of Lagrange by multiplying has a gradient f ka gradient g ka and is proportional and this lambda is the Lagrange multiplier. So C condition is satisfied. This condition should be satisfied. So that means 3i plus 4j, 3i plus 4j should be equal to lambda times 2xi plus 2yj. From this, you compare the coefficients of I. Coefficient compared to wrong. So this is 3. This is 2 lambda x. So see vector anism managari for two vectors should be equal. Magi corresponding x component managadavani, corresponding y component managadavani. So left hand side ki vector is x component kaino 3 ne. So ki x component kaino 2 times lambda x. So 2 times lambda x equal to 3. Similarly, y component so managadavani, so ki y component kaino 4 ni. So ki y component kaino 2 times lambda y. So 2 times y lambda should be equal to 4. So condition you can easily solve x equal to 3 by 2 lambda, y equal to 2 by lambda. 4 by 2 lambda near 2 by lambda tahorebo. X and y value in terms of lambda. Next step I should substitute these two values of x and y in the constraint equation. In this constraint equation, either the hapusiare, so just the hapusiare. So you substitute these values of x and y in the constraint equation. So these points must lie on the circle given by g equal to 0. So x square plus y square equal to 1. You put x equal to 3 by 2 lambda, so you get 9 by 4 lambda square. Y equal to 2 by lambda, so you get 4 by lambda square equal to 1. From this, you solve lambda. So you lambda solve and you get two values of lambda. Lambda can be plus 5 by 2 and minus 5 by 2. Lambda give value only okay. Now let us consider the case. Lambda equal to 5 by 2. When lambda equal to 5 by 2, lambda equal to 5 by 2, what will be x? What will be y? See equation different values of lambda, different values of x and y. So when lambda equal to 5 by 2, we get x equal to 3 by 2 lambda. 3 by 2 lambda, you put lambda equal to 5 by 2, you get x equal to 3 by 5. And when lambda equal to 5 by 2, you get y equal to 4 by 5. There were two possible values of lambda. Lambda possible values amana plus 5 by 2, amana minus 5 by 2. So when lambda equal to plus 5 by 2, the values of x and y are given by 3 by 5, 4 by 5. When lambda equal to minus 5 by 2, the values of x are minus 3 by 5, minus 4 by 5. There you go. So what is f now? F is 3x plus 4y. So I have x y value now x c y c x this y this. So first let us put x equal to 3 by 5, y equal to 4 by 5 in this expression. I repeat. First let us put x equal to 3 by 5 and y equal to 3 by 5 in this expression. What do we get? We get the maximum value of f is given by x equal to 3 by 5, y equal to 6. And what do we get? We get value 5. There you go. So this 5 is the maximum value. X ko y negative, we get the minimum value. And the minimum value of f is given by 3x plus 4y. x is minus 3 by 5, 4 is minus 4 by 5, y is minus 4 by 5, and we get minus 5. So this is the minimum value of f, this is the maximum value of f. And this is how we calculate, we maximize or minimize the value of a given function subject to a constraint. So this is the idea. Idea now, method of Lagrange multiplier and p value say it gives us the extremum value. Extremum value. And for this particular example, we can find both the maximum and the minimum value. In my earlier example of a cuboid, we calculated only the maximum value. Method of Lagrange multiplier is extreme value extreme value to maximum minimum question particular example is extreme value ani plus 5 ka minus 5 ka maximum minimum. But in our earlier example which we discussed about the cuboid with maximum volume, we calculated the extremum value, and from physical considerations we took that extremum value to be a maximum value. Physical considerations tagi extremum value do maximum ni minimum ni for simple examples. But for more complicated examples, method of Lagrange multiplier method of Lagrange multiplier gives us only the extremum value. And to determine whether that extremum value is a maximum or a minimum, we require some other calculations. Physical meaning to clear for complicated examples, for complicated exercises, Lagrange method of multiplier only the extremum value never. High extremum value z maximum minimum we need more calculations. But that is beyond the scope of our course. What we do here is only we find the extremum value of a function. Maximum value, minimum value have the physical context. Let me give you another example. Let me give you another example. Okay, this example. The temperature at a point xy on a metal plate T on a metal plate is this. This is the expression for temperature. This is the expression for temperature. An ant on the plate walks around the circle of radius of 5 centered at the origin. What are the highest and the lowest temperatures encountered by the ant? So, when given problem, temperature pyramid, the temperature is given by this expression, and this expression is nothing but 2x minus y whole square. We have to find the maximum and minimum value of this temperature. Now we have to find the extremum value of this temperature subject to the condition that the ant is moving on a circle with radius 5 and centered at the origin. So this is the equation of a circle centered at the origin and radius 5 units. So see to 25c, we bring on the left hand side and write this expression as g and equate it to 0. So this is the equation of a circle with center at the origin and radius 5 units. So this is the constraint. This is the constraint equation because the ant is moving along this curve. Method of Lagrange multiplier at the point of extremum, or that is at the point of maxima or minima, the gradient of t should be equal to lambda times the gradient of g. So first let us calculate the gradient of t. Gradient of t, what carry, you differentiate t with respect to x first. So if I differentiate with respect to x, this will be 8x. 8x minus 4y. So 8x minus 4y, I kept. When you differentiate this with respect to y, it will be minus 4x plus twice y. Minus 4x plus twice y times j. So this is gradient of t. Now let us calculate the gradient of g. So gradient of g, what you differentiate this with respect to x, you get twice x, I kept. This, if you differentiate this with respect to y, you get twice y plus twice y, j cap, multiplied by the parameter lambda. There you go. So from this equation, you simplify it. Simplified. Okay, we can compare the x components and y components separately. This is a vector. This is also a vector. Vector any equal. Their x components should be equal. Their y components should be equal. So the x component is this 8x minus 4y. Magi x component twice lambda x. Mana recall. Sigi y component this minus 4x plus twice y. Sigi y component twice lambda y. So this equation we obtain by equating the x components. This equation we obtain by equating the y component. Then we simplify. So you take 4 common doctor. You divide throughout by 4, you get this expression. You divide throughout by 2, you get this expression. Here it is twice x minus y. Here this is minus twice x plus y. These two are negative never. So if you multiply this by minus 1, you get this expression. That means this is equal to minus this expression. From this, you take this to the left, you get lambda times x plus twice y equal to 0. So I have the product of two numbers equal to 0. That means either of the two numbers are 0. So there are two possibilities. Either lambda is 0 or x plus twice y is 0. So let us consider the first case. The first case when lambda is equal to 0. So case number 1. When lambda equal to 0, case number 1 lambda equal to 0. Lambda is 0 you put lambda equal to 0 here. You put lambda equal to 0 here, what do you get? Twice x minus y equal to 0 minus twice x minus y equal to 0. This two will give you the same equation. This. From this you get y equal to twice x. So you get y equal to twice x. You get a relation between x and y. Then you substitute this in the constraint equation. So substitute this in the constraint equation. What do you get? X square plus y twice x, so twice x whole square for x square equal to 25, you get x equal to plus minus 5. So when x equal to plus 5, y equal to 2 times root 5. When x equal to minus 5, y equal to minus 2 times root 5. And so what is the expression for temperature? The expression for temperature is this. Which can be simplified by twice x minus y whole square. So this is x, this is y. So in this expression, if you put x equal to root 5, this will be 2 root 5. If you put y equal to 2 root 5, this will be 2 root 5 minus 2 root 5, the answer will be 0. Similarly here, if you put x equal to minus root 5, this will be minus 2 root 5, this will be minus 2 root 5. And if you put y equal to minus 2 root 5, this will cancel out and it will again give you 0. So at this critical points, these 2 points, at these 2 points, the temperature is 0. That means the temperature is lowest at these 2 points. So when the n moves along that circle, at these 2 points on that circle, the temperature encountered by the end will be 0. Right? So case number 2 so case number 1 lambda equal to 0 case na lowest point, the minimum of the function period. Now let us look at the second case. What was the equation? The equation was this. Either lambda was 0 or this was 0. So second case, this is 0. So let us consider second case. Case number 2 is x plus 2y equal to 0. This means x equal to minus 2y. So substituting x equal to minus 2y in the constraint equation, x equal to minus 2y in the constraint equation, we get y equal to this 4y squared plus y squared equal to 25 plus y equal to plus minus root 5. Y equal to plus minus root 5. Right? So y equal to plus minus root 5. When y equal to plus root 5, x equal to minus 2y. So when y equal to plus root 5, x equal to minus 2 root 5. And when y equal to minus root 5, x is equal to minus 2y, that is plus 2 root 5. Now you substitute these values of x and y in the expression for t. Temperature is Aduna, critical point anisda at these two critical points, you calculate t twice x minus y whole square. So this is x, this is x, this is y. So t of this is equal to twice x minus y whole square, which is 125. Similarly, t calculated at these 2 points is also twice x minus y whole square, which is again 125. Thus, thus temperature is maximum at these points. Thus the temperature is maximum at this point. So what do we get? At these 2 points, when the end moves along the circle, at these 2 points, the end encounter the highest temperature, and that highest temperature is given by 125. So the temperature is maximum at these 2 points. Question what are the highest and lowest temperatures encountered by the end? So the highest temperature encountered by the end is 125, and we can call it 125 Kelvin, and the lowest temperature encountered, we can call it 125 degrees Celsius, and the lowest temperature is given by 0 degrees Celsius. So this gives you the lowest temperature, this gives you the highest temperature. So aduna akonba discuss the example anish dadi maximum minimum animal. But in some cases you will find only one extremum value. You will find only one extremum value, and from the physical interpretation of that problem, you can guess whether that extremum value is either a maxima or a minimum, maximum or a minimum value. And if that is the physical interpretation, the maximum and minimum have a guess, then we have to take the help of further calculations. Further calculations we discuss already. So the important point method of Lagrange multiplier gives us the extremum values, and from those extremum values, sometimes we can decide which is the maximum, which is the minimum, and sometimes we cannot decide whether the value we get is the maximum or the minimum. Okay.